Man, I know you guys are pumped up to do our second midpoint problem, not in the coordinate plane though, so be careful. And this one's very similar to the last one. It's a little bit more challenging because we have all variables for our segments. We don't have any just, values like a 4 or something. So this one's a tidbit more challenging, but really not that much harder. So if you think you understood example 6, I encourage you to try this one on your own and then see if you get the right thing in the end. But anyways, it says I is the midpoint of PG. If PI is 2x plus 5 and IG is 6x plus 1, find x, PI, IG, and PG. So there's lots of things we're solving for. And again, you guys, since we don't have a picture, it's always helpful for you to draw a picture so you can kind of visualize what's going on. So I'm going to draw my picture. I'm going to draw a segment, which means it's got to have some endpoints on it. And the endpoints are PG. It's segment P to the G. And it says I is the midpoint. So halfway I'm going to make I my midpoint. And holy hot dog, it spells pig. Again, I love when my segments spell names. So I is the midpoint of PG, and we know that midpoints create two congruent pieces. So I'm going to mark that PI is congruent to IG. So segment PI, I know is congruent to IG because that's one of the properties of our definition of a midpoint. So we know that. All right, and if we know the segments are congruent, it also implies that their lengths are equal. So if I don't include the segment pieces, I can say that their lengths are equal. So that's going to be useful. Okay, it says if PI equals 2x plus 5, so PI is 2x plus 5, and IG is 6x plus 1, then we would need to find x, PI, IG, and PG. Alright, so let's get going. So if I know that PI and IG are equal, how do you think we could solve this problem? Holy hot dog, you guys are so smart. If PI equals IG, I can just set these two bad boys equal to each other, which will help me to solve for x. Okay, so I'm going to basically use this statement and substitute in the pieces where they belong. Okay, so I'm going to use the statement PI equals IG. So PI equals IG. Alright, let's substitute these values in for what they equal. So PI is 2x plus 5. Bring down my equal sign. And IG is 6x plus 1. Alright, let's start solving this thing for x. And again, if you know to solve for x, do not waste your time watching me do it. You can do it on your own. Alright, so let's get going. So, first of all, I need to bring my x's together because they're besties. Alright, so the way I'm going to do that, I'm going to bring my positive 2x to the other side. And the way we bring a positive 2x to the other side is by subtracting it on both sides. Bam! 2x minus 2x cancels and turns to 0. 6x minus 2x gives me a 4x. Okay, so what I'm left with is 5 equals 4x plus 1. Alright guys, now that my x is on one side, I need to bring everything else to the other side. So the way I bring a positive 1 to the other side is by subtracting it on both sides. 1 minus 1 cancels and turns to 0. 5 minus 1 becomes 4. So this is 4 equals 4x. And then finally, the way we bring 4 to the other side, since it's secretly multiplying to the x, the way we bring it to the other side is by dividing it on both sides. So 4 divided by 4 cancels and turns to 1, and 4 divided by 4 also will turn to 1. So we end up with x equals 1. Yay! Alright guys, so we found x, but we're not done. We gotta find PI, IG, and PG. So let's start solving. And technically, you guys, I know that if I solve for PI, technically I know IG, but it's good to solve for both just in case you did something wrong. Okay, so let's start solving this thing. We're going to solve for PI, which equals 2x plus 5. And we're going to solve for IG, which equals 6x plus 1. Alright, so let's start solving. So I'm going to be replacing my x's with what the x equals. So my x equals 1, which means the x's here are going to transform into a 1. Okay, so pi equals 2. My x is going to change into the 1 down here. All right, let's solve. So 2 times 1 gives me 2. So pi equals 2 plus 5, which means pi equals 7. Yay! So if I do this correctly, you guys, if pi is 7, technically my ig should also be 7. So let's see what happens. So ig equals 6. My x is going to transform into a 1. 6 times 1 is 6. And 6 plus 1 gives me a 7. Holy hot dog, we did it right, you guys. Yeah, it's awesome when we do it right. All right, guys, and then finally, we need to solve for PG. So I know that this is 7 and that is 7. So let's see here. If I know this piece is 7 and this piece is 7, how can I find the length of the whole thing? Well, there are several ways to do it. Just like this one, there's 3 different options. There's actually probably more than that. I'm just going to show you one, though. But if you have a better way or a way that you prefer, I highly encourage that you try it that way. All right, so PG, the way I'm going to do it, PG equals PI plus IG. This is called the segment addition postulate, which states the entire segment equals the segments that are within it added together. So PG, the whole thing, will equal PI plus IG. All right, so I'm going to bring down my PG. PG equals my PI equals the 7, so it's going to transform into the 7, plus my IG, which also equals 7. So my IG just transformed into the 7. And 7 plus 7 is 14. So my PG is 14. Yay! And guys, this is a G. I'm sorry, my G is struggling in here. So P to the G is 14. That whole piece. Yay! So we know X is 1. We know PI is 7. IG is 7. And PG is 14. And look here. We solved for everything we need to solve for. Yay! So I know that you guys are super excited about finding something about midpoints just in space. But now we're going to take midpoints to a coordinate plane, which will be super fun. So we're going to see them on a graph, which that involves a nifty formula. So look forward to doing example 8 when we use coordinate geometry to find the midpoint. I know you guys can't wait.